Okay, the first thing I'm going to do is I'm going to have the answer key posted up here, and you can ask your substitute to please press pause if you need additional time to check, but I'm going to talk through them fairly quickly. Now, A and B on your homework packet last night were fairly easy. When you looked at your list of possible rational roots, we could see them all on the graph. So there was no synthetic division that we had to do to identify any missing roots. We know that 2 is a root, and it passed through at that point. It was tangent at 3, so we know that that is a double root. So if we count our roots, there's 2 here because it's considered a double, plus 1 makes 3. We're done, and both of these were rational. Here's our complete factored form of that answer. B, if we look at our list of possible rational roots, what we can see on our graph is everything, because this gives us, once again, a double. This time the double occurs at 2, and this should be rational. And then we also have a root at -4. So the 2 plus the single makes 3. We got them all. We write our complete factorization. All right, if you need to hit pause for a moment to continue correcting this page, that's fine. And when you're ready, press play. Okay, and here we have C. If we look at C, we have this graph. These are our possible rational roots, and on this graph it's going to cross at -2, and there'll be an inflection point there because this is a triple. And you could do synthetic division with the -2, and then when it factors, we would be left with x squared plus 4x plus 4, which factors to x plus 2, quantity cubed. So that gives us the triple that occurs at -2. Okay. D. On D, we are looking on our calculator for our zeros occurring at 1, +1 or -1, +3 or -3, and 9. So hopefully you saw it at +3. You use synthetic division for that, and you're left with this, 1, 0, -3, which represents x squared minus 3 equals 0. You solve, and you get x equals positive or negative square root of 3. So we have the 1 rational root and the 2 irrational roots. If we wrote it in factored form, the function would look like this. But if I ask you for the complete linear factorization, it would be this bottom row, where we break this down into x plus or minus those square roots. Okay, let's take a look at E. Had a nice short list of possible rational roots on this one, plus or minus 1 and plus or minus 2. You should have seen on your calculator that -2 worked. Therefore, when you use synthetic division here, we get 1, 1, -1, which represents x squared plus x minus 1. When we use the quadratic formula for this, because it won't factor, when we plug it in over here, you get -1 plus or minus root 5 over 2, which is our root. So here we go. -2 is rational, -1 plus root 5, all divided by 2 is irrational, and -1 minus root 5, all divided by 2 is also irrational. But if we were to write the complete linear factorization, we would have to take this part and figure out what that would look like as a factor. Well, we know this would need to equal 0, so we want to turn this part into 0. First thing you do is multiply both sides by 2, add the 1, and then add or subtract the root 5. So these are my factors, 2x plus 1 root 5 and 2x plus 1 minus root 5. And there's the complete linear factorization. If you need to hit pause, please do so now. Okay, F. These are our possible rational roots. We can see from our graph that 2 is a root. So we use 2 on synthetic division. It leaves us with x squared plus 4. Easiest way to solve this one, move the 4 over, take the square root of both sides, and you get x equals plus or minus 2i. So here is factored form, but here's the complete linear factorization, where we divide this into factor x squared plus 4 into x plus 2i and x minus 2i. So our roots are 2, 2i, and -2i. 2 is rational, 2i and -2i are both imaginary. Now, anytime I have circled rational or irrational, those fall into the real category. Since I circled rational or irrational, I'm assuming you know that both of those fall under real. Okay, Now we're to the higher degree polynomials, and you can't quite see it, but what my list of possible rational roots are 1, 2, 3, and 6, plus or minus. Well, we can see them all on our calculator. Absolutely no need to do any work. So I would not do any linear, I would not do any synthetic division on this one. You can just write it out and keep moving. Okay, B, same thing. Here's my list of possible, which is really long, but luckily we can see everything on our calculator. It passes at -3, it is tangent or bounces at 2, and it passes at 3. So we would count this as 2, one more makes my 4. I'm all done. I don't even have to do synthetic division to look for any other roots. I can account for them all. If you need, go ahead and press pause. When you're ready, press play. Okay, once again, we are doing the same exact thing every time. We're looking for those zeros that we can see on our calculator, which for this one, -2 and 4, which was great because we have a 4th term. So we got to get it down to a quadratic. So when we do the synthetic division by -2, it takes us to this line with a remainder of 0, which is what we have to be a 0. And then we do 4, and we get this line, which gives us x squared plus 2x minus 2. This does not factor, so we'd have to use the quadratic formula. And you see we get this here. So the -2 is divisible by 2, and the 2√3 is also divisible by 2. So this is where these solutions came from. And this should be plus and plus. There we go. Now we're right. So you would get the x minus the -2, which makes plus 2, x minus the 4, x minus all this, which would change the signs, and x minus all this, which would change the sign. So I left out those negatives. It's been corrected now. So take a look at that. All right, on D, we're going to do the same thing, but when we're down here to this line, we set it equal to 0 and solve. And this time we get our 2 rational and we get 2 imaginary. So here's the factored form, but here's the complete linear factorization. If you need to press pause to correct your homework, do so now. These notes will also be posted on my website. All right, E. Now, this one, when we looked at these, you might want to change your counting number on your calculator. If you go to second and window, you'll see it says table set, and you can see my zeros have to be somewhere between -2 and +2, so I might have my table start at -2 and hit enter, and you ought to see this delta triangle looking thing table. That means the change. What do you want it to count by? Well, this counts by, our smallest one on here is a 4th, so you might want to have it count by 0.25s. And then when you look at your table, you'll see that 0.5 is a 0 because it'll show up now. And you can see that clearly. Or you could have just used the zeros button on the graphing function and found that 1/2 is a double because it's tangent there. And then we can divide by it twice because it's a double. And then set this equal to 0 and solve. So you get your 2 rational, your 2 irrational. Here's complete factored form. Here's the complete linear factorization. Press pause if you need to take a moment. All right. We continue, same thing. We can see all 3 of them on this one, so just write them down. There's an inflection point here. That's a triple. So that's 3, 4, 5, and it was a 5th degree polynomial, so we're good. On this one, we can easily see the -3, and we see something's happening at 2, and it's bouncing, so we'll do it twice. Well, it turns out what's left shows it doesn't just do it twice, because we can tell it's even if it's tangent. It actually happens 2 more times. So the double plus a double makes a multiplicity of 4 here. So we would write it as x plus 3 times x minus 2 to the 4th. And I believe this is your last one. These are our possibles. So we see there's a double at 1. We'll do it twice. It passes at 4. We'll do it again. And then we take what's left. We set it equal to 0 and solve. And we get the 2 imaginary. So we have 3 rational, 2 imaginary, factored, complete linearization, factored form. And that's it. Okay. Today we are going to work on problems that kind of stem from what we've been doing. So if you'll take out some notes, we're going to take out a notebook paper. We're going to take a few notes, and then you have a worksheet to work on today. Okay, the first example we're going to do, this is when I give you not a real, but an imaginary solution. So what I'm going to do is I'm going to say that 2i is a zero of this function. And the function is x cubed plus x squared plus 4x plus 4. So this is our function, and you might notice that we could do this by factoring, and that would be a good way to check this one, but let me show you what to do. And I'm going to give you some that don't factor nicely, so here we go. I'm telling you that 2i is a zero, so I should be able to do synthetic division with this imaginary number. We do it the same way. But now we're just dealing with some imaginary. So we pull off our coefficient and our constant. We bring down the first term. We're multiplying by the imaginary. And we're adding. So this term right here looks like this. 1 plus 2i. And then we're multiplying. So what happens when I multiply 2i times a 1 plus 2i? 2i, and I'm just going to do it off to the side. Most of you could probably do this in your head. And what do we get with the I squared? It turns it into a negative. So this becomes negative 4 plus 2i. Well, isn't that nice? What happens to the 4's? They're going to cancel when we add right here, and we're left with 2i. And then 2i times 2i is negative 4. Oh, yes, it is a zero. I have a remainder of 0 here. Now, if 2i is a zero, its conjugate must also be a zero. So if 2i is, then I ought to be able to do negative 2i here. We'll bring down that first one. We'll multiply and add. We'll multiply and add. And that worked out very nicely, because if we look at this, we're left with x plus 1 as one of my factors. Another factor would be x minus 2i. Another factor would be x plus 2i. Where'd these come from? This and this came from here. If those are zeros, these are factors. So this would be the complete linear factorization of the problem, which is what I'd like you to do for step 1. And then on your homework, I would like you to give me all the zeros. Negative 1, 2i, and negative 2i. So the complete linear factorization and the list of all possible zeros is what I'm looking for. I have 2 more examples for you, and then you can start your worksheet. Number 2, 2 plus 2i is the given zero. The function is f of x equals x to the 4th minus 4x cubed plus 12x squared minus 16x plus 32. So what we're going to do here is this is our zero. Our coefficients are 1, negative 4, 12, negative 16, and 32. And I spaced them out a little more because I knew I was going to have some imaginaries going on here. So we'll bring down this first one. We'll multiply, and that gives us 2 plus 2i. And we're going to add, which gives us negative 2 plus 2i. Real with a real, imaginary with an imaginary. Now I'm going to multiply this times this. And you may have to do a little work over at the side when you do this multiplication. So when we do this, we're going to get negative 4. If we look at the outer and inner, we should see they're opposites, so they're going to cancel. So plus 4i squared, well, the I squared is a negative 1, so this gives us negative 8 here. And if you're looking for where that came from, it came from there. All right, so this gives me 4, and then when I multiply, it's 8 plus 8i, which gives me negative 8 plus 8i. And then when I do negative 8 plus 8i times 2 plus 2i, a nice thing happens, and I get negative 32. You can prove that for yourself in a minute. All right. Just a minute ago I told you, and I'm going to move this out of my way real quick. All right, I told you, if this is a zero, its conjugate must also be a zero. Conjugate time. So that's what we are dividing by. We bring it down, we multiply, and nice things happen. We add, we multiply, we add, we multiply, and nice things happen. So it turns into this really pretty x squared plus 4. So if we wanted to know what the zeros are, we could set it equal to 0. And that becomes -4. So x equals plus or minus 2i when we take the square root of both sides. So if I were to list my zeros are 2i, -2i, 2 plus 2i, and 2 minus 2i. I've got 1, 2, 3, 4, and the degree of the function is 4. I have them all. Now the complete linear factorization would look something like this. X minus this one, x minus this one, x minus this one. And when I got to multiply that negative through there because it's minus the whole thing. And then x minus that one. And that's a complete linear factorization. Okay, now sometimes when we get to this level, we may have a quadratic that you still have to use the quadratic formula for. And that's fine. So let's do one like that, and then we'll be done. Last example, example 3. If we have one factor, of -2i for this function, we're going to do a 4th degree again. Okay, so what we would do is we would put the -2i here. We'd have 1, -4, -16, -16. And I'm just going to show you what the result would be. We get the -2i, so that's -4 minus 2i. You multiply this times this, and we would get oh, what did I do, folks? I left out my 0. Do you see there's no squared term? I'm like, this is not working out pretty. Okay, left out my 0. Don't go so fast that you do that. So here we should have -2i times this, and it will turn into -4 plus 8i. So that gives me -4 plus 8i. And then we multiply this times this. It'll give me 16 plus 8i. So that simplifies to just 8i. And then -2i times 8i ends up being positive 16. So my remainder is 0. So if -2i is a 0, then positive 2i must also be a 0. Bring down the first one. I'm going to multiply, and that cancels, and it leaves me -4. I'm going to multiply. That cancels, and it leaves me -4. I'm going to multiply. This cancels, which is good, because it better have a remainder of 0. So I get x squared minus 4x minus 4. If this had been plus 4, it would have factored, but since it's minus 4, it doesn't factor. So we're going to have to use quadratic formula. So we're going to do -b plus or minus the square root of b squared minus 4 times a times c. That's a -4 all over 2 times a. And this is going to give us 4 plus or minus 4 roots of 2 when we simplify over 2, which is 2 plus or minus 2 roots of 2. So my zeros are -2i, positive 2i, 2 plus 2 roots of 2, and 2 minus 2 roots of 2. So the factored form would look like this. If I had the complete linear factorization, it would be f of x equals x minus first one, which makes it a plus 2i. X minus the second 0, minus 2i. X minus all of this, minus 2 root 2. X minus all of that, x minus 2 plus 2 root 2. And that's the complete linear factorization. Okay, guys. You have a worksheet to work on. You may help each other out, and I'll be here tomorrow to answer questions.